Okay, today we're going to talk about a few more exponent laws. The first one we're going to talk about are negative exponents. So negative is like a code word saying your base is in the wrong spot. Okay? So to make a negative exponent positive, the rule is that we have to move the base from the numerator to the denominator or vice versa. So, upstairs, downstairs, downstairs, upstairs, whatever. What are we even talking about? Okay, let's write an example and figure it out. So let's see. If I gave you x squared divided by x to the 5, okay, let's expand that out and see what happens. Well, you've got 2 x's up top. You've got 5 x's in the bottom. So let's cancel out. So cancel here. This one cancels with that one. This one cancels with that one. So I'm left with 3. But the ones that I'm left with are down in the denominator. So my final answer here is going to be 1 over x cubed. Okay. Now if I hadn't have expanded it, if I had followed my rules from yesterday, let's think about doing that. So our rules yesterday said that when we are dividing, we need to subtract our exponents. So I could have said 2 minus 5. Well, that would have given me negative 3 as my exponent. So my negative 3 right now I'm in a numerator is the same thing as a positive 3 in the denominator. So therefore, I can say x to the negative 3 is 1 over x to the 3. So there's my rule in action. That negative exponent really means to put it down into the denominator. Okay, so this is important. This is today's mission. Okay? Okay, let's try another example. This time I'm going to put my negative 4 outside of the brackets, and let's see what this does. Well, if I follow my rule, the negative exponent means that my base, which in this case is negative 3, belongs in the denominator. And now I've got a positive exponent. Now don't forget that exponent is still counting for that whole negative 3. So to finish it off, I have 1 over negative to any even numbered exponent is going to give me a positive. So I'm going to end up with a positive 3 to the exponent 4. So 3 times 3 is 9. 9 times 9 is 81. So it gives me 1 over 81. And don't forget, you can always look that up on your table. 3 to the exponent 4 is 81. Okay, how about this example? Now I've got a full fraction in here, all to the exponent negative 2. Now we know from before that that exponent affects everything inside the bracket, which means that the negative applies to everybody in the bracket. So one way to handle this question is we're just going to trade places. So my 6 is going to come up into my numerator, and my 5 is going to come down into my denominator, and now I have a positive exponent. Because remember, the negative exponent means I need to move my numbers, in this case numerator to denominator, denominator to numerator. Now everybody's going to get the square, so it's going to come in. So I've got 6 squared over 5 squared. So my final answer for this one, 6 squared is 36, 5 squared is 25, and there's my final answer. Okay, this example comes straight from your textbook, and it's a nice complicated one. So that's fine, we can do it, just take each of your rules one at a time, okay? So the first thing I'm going to do is I'm going to simplify my numerator, and when I have the same base multiplying, I'm going to add my exponents. So that means I got a negative 4 plus 8 is in my numerator. My denominator, let's simplify it out, because I have a power of a power, I'm going to multiply exponents. So you get 5 to the negative 3 times 2. And I'm going to simplify using my rules first before worrying about negatives, because sometimes the negative disappears. Okay, so let's see if that happens here. I end up with 5 to the exponent. Well, let's see. Negative 4 plus 8 gives me a positive 4. Denominator becomes 5 to the exponent negative 6. Okay. Well, now I've got the same base and it's dividing, so let's subtract my exponents. So you end up with 5 to the exponent 4 minus negative 6. And when you're subtracting a negative, hey, guess what? That becomes a plus. So you really have 4 plus 6. So in this case, I didn't even have to worry about negative exponents. It simplifies out to 5 to the positive 10. And if we look that up on our nice little handy dandy chart, 5 to the exponent 10, it's going to be big. 5 to the exponent 10, is it even there? Yes, it is, all the way at the end. Oh boy. 976 5625. 5625. That, my friends, is a massive number, but that's what happens with exponents. So you get a really big number really fast. Okay, so last rule, we kind of do have to discuss what happens when you end up with a zero exponent. So, I don't know. Let's see. If I had 5 divided by 5, well, everybody knows that if you take something and you divide it by itself, you're left with 1. Okay. What if I looked at that in terms of exponents? So this would really be 5 to the exponent 1 divided by 5 to the exponent 1. And we know our rule is that when we're dividing, we are subtracting. So according to my rules, that would give me 5 to the exponent 0. Ah, look at that. Anything to the exponent 0 is going to be equal to 1. Nice. That's my rule. Equals 1. Let's try another one. Let's say I have x cubed divided by x cubed. Again, it's something divided by itself. Well, this time let's write everything out. X times x times x all over x times x times x. So I have 3 in the top, 3 in the bottom. So what do we do when we're dividing like this? Well, we can cancel, right? So let's cancel x with x, that one and that one, and I got nothing left. Oh no. Well, you can't have a final answer of anything other than 1. In this situation, when they all cancel out, it equals 1. And if I followed my rules, well, if I did x to the 3 minus 3, well, 1 equals x to the 0. And that's it. That's the rule. It's nice. Doesn't matter what I put in there. I could put like the most complicated, nasty, awful thing. I could say 100 squared x cubed x to the 5 y 20 all to the exponent 0. And because I've put it up to that lovely little 0, my answer is